Today we're going to talk about angles like 180 plus x or minus x, 90 degrees plus x or minus x, and see how trigonometric functions, namely sine and cosine, of those angles related to sines and cosines of angle x. Okay? So for this demonstration, let's look at x, which is between 0 and 90 degrees. And first we're going to consider the angle 180 minus x. Okay, it's an angle like this. The point A, in this case, which lays in the second quadrant, going to have coordinates cosine 180 minus x and sine 180 minus x. So what we want to look now at is a triangle ABC. Okay, this is a right triangle. Okay, and if you look carefully, you find that angle B in that triangle equals to x. Why? That's because that angle plus 180 minus x together should give me a straight angle of 180 degrees. So, but now, if you look at this right triangle ABC, and if we remember what sines and cosines, how they define through the sides of a right triangle, you would remember that AC would be in opposite leg of angle B, which is x, and the sine of that angle B will be the opposite leg divided by hypotenuse. But hypotenuse is our radius, and it's the radius of unit circle equals to 1. So essentially what I'm saying that is AC equals to sine x. Okay? In a similar way, we can show that BC, the adjacent leg, should be equal to cosine x. So now let's look at the vertical coordinate of point A. On one hand, it is sine of 180 minus x. On the other hand, it equals to the length of this triangle, vertical leg of the triangle, AC. And AC equals sine x, which means that sine of 100 minus x equals sine of x. Now, if we look at the horizontal coordinate of the point A, that is cosine of 180 minus a. Okay? And the first thing we can quickly say, oh, in this case, cosine of 180 minus x should be equal to BC and equal to cosine x. But if you think about it a little bit, you find that although point C and point A lay exactly distance BC from the vertical axis, it's laying in the negative direction. So while cosine x is positive, cosine of 180 minus x is negative. So the correct relationship is cosine 180 minus x equals minus cosine x. All right? So let's move on and let's look at the angle 180 plus x. Now, in this case, we'll find our familiar triangle ABC. Now it got flipped. It's sitting right here. Okay. And this angle is x. Again, as in the previous case, AC will be opposite leg of this triangle, opposite leg of angle B in that triangle ABC, and will be sine x, and BC will be cosine x. All right? But now notice that BC as a length is positive, but the coordinate, horizontal coordinate, is negative as before. Right? And also, notice something different, that vertical coordinate of point A is actually negative, while AC is positive. So really what it means that sine of 180 plus x will be minus sine x, and cosine 180 plus x will be minus cosine x. All right. Next thing we consider is angle 90 plus x. Again, let's find our triangle. In our triangle, and it changed a little bit. It's again ABC, our right triangle. Angle B again is angle x. AC again sine of x. BC is cosine of x. Right? But now look what's happening with the vertical coordinate. Vertical coordinate of point A, sine of 90 plus x, equals to the length BC. But length BC is cosine x now. So sine of 90 plus x will be cosine x. Now, when it comes to horizontal coordinate of point A, it's cosine of 90 plus x. It corresponds to length AC, horizontal length AC. But again, AC is positive, but cosine lays in the negative direction. So we get cosine of 90 plus x is minus sine x. And the last thing we're going to consider is the angle 90 minus x. In this case, again, we get our triangle, ABC. Angle B again is angle x. And as before, AC is sine x, BC is cosine x. You now notice that vertical coordinate of point A, sine of 90 minus x, equals to actually length BC. Okay? So sine of 90 minus x is cosine x. They're both positive. And cosine 90 minus x, horizontal component, equal to AC and equals to sine x. Okay? So now let's look at all these formulas we got so far. So we got 8 formulas. All right? And the question is first, why bother? What do they give us, these formulas? First of all, if you remember, we talk about how to find sine and cosine of 30, 60, and 45 degree angles. So these formulas allow us to expand the angles we can deal with, or sines and cosines, or what angles we can find. So for example, if somebody asks you to find a sine of 120 degrees, you can quickly say, well, 120 degrees is 90 plus 30. So we're looking at sine of 90 degrees plus 30 degrees. In this case, we're going to look at this formula, sine of 90 plus x. And we know it's a cosine x. So it should be cosine of 30 degrees, and we already know cosine of 30 degrees is square root of 3 over 2. Let's consider another example. That is cosine of 135 degrees. Well, we can look at 135 degrees as 180 minus 45 degrees. Now, we're looking at this formula, cosine of 180 minus x, and that is minus cosine x. So it's minus cosine of 45 degrees. You know cosine of 45 degrees is 1 over square root of 2, and cosine of 135 degrees is minus 1 over square root of 2. Okay? So this is how we can use these formulas. They are very useful. Now, the next question is, okay, but, you know, there are a lot of them. And we actually don't look at all of them. We also could have looked what's happening if I have a sine of 270 degrees plus x or minus x. How would we handle that? And actually, you can try to do it the same way as we did here. I'll leave it as an exercise. But when you have a problem in in school, often they ask you to remember these formulas. And you can say, well, this is insane. There are too many formulas, I can't remember them all. Okay? How can I do this? Because I don't want to derive them every time when I use them. So here's the good news. There is a trick you can use to kind of get these formulas. And in one of the future videos that are coming, stay tuned, I'm going to talk about those formulas. Sorry, I'm going to talk about that trick. And the last thing I want to talk about is about this angle x. So far in the derivation of the formulas, we use the fact that x is between 0 and 90 degrees. But what if it's not there? These formulas still work. The good news is they do. It doesn't matter what x is. You can take x from minus to plus infinity, anything you want, and the formula's still gonna work. So if you don't trust me, don't believe me, you can try. Let's say pick up one formula. Let's say we pick up cosine of 180 minus x and assume x is between, let's say, 90 and 180 degrees. Draw the picture, draw the triangles, and try to prove this formula. Good luck. See you in the next video.